Hello from 2025 summer. And due to my impetuousness and the Captain Carey's personality, inevitably I couldn't keep up with the YouTube channel, so the topics we have recorded hitherto are not consistent and are not synchronized with what I am doing today, right now. Because right now I am driving the field equations, gravitational field equations with respect to Einstein's theory, the field equations actually. And what we have recorded hitherto are the videos of inflationary cosmology that are solved with respect to zero Hamiltonian system. Zero Hamiltonian that led us to Friedmann equations that describe the expansion and the inflation of the universe with respect to density of cosmic fluid and the geometry, which the energy densities are distributed along homogeneously. For instance, that was actually the first assertion that is required to make the case much more easier than it is today. And we just continued our equations for three essential models of the universe, right? Those are actually the cosmic dynamics. The fact that so as to synchronize the topics, the fields, I suggest a solution such that we will record one more video about astrophysical facts, the observational validations of the cosmology, by the discussion of the Maxwell's equations in the medium, and maybe relativistic electrodynamics, for instance. And afterwards, we will start another series. And I will actually, the very auspicious intention of such a preference is that I intend to derive the field equations first with respect to tensors and tensors algebra, and afterwards I will solve them. For Schwarzschild's black hole, of course, for that can be solved with respect to many different miscellaneous energy momentum energy tensors, so you can solve them with respect to different kind of matter and fields. We will solve them respectfully, but first our preferences will be, so as to understand the theory, the vacuum solutions of Schwarzschild, the linearized Einstein's theory for gravitational waves, and afterwards we will deal with the compact stars, so we can explain the entire behavior of any star in the universe. That is also possible. And afterwards, the cosmic dynamics, Robertson-Walker dynamics of cosmology. Those are actually four essential topics for our intentions in the cosmology, but they will be called the gravity, the general relativity theory. So the new series will be started in 2 months, okay? I will record regularly, I hope so, because I am really busy with gravitational field equations, and of course the thesis, well, it is completed, but we are now doing relativistic quantum mechanics by solving Klein-Gordon's equation, so it will take time, because the corresponding geometry in which we are solving the quarkonium is really hard. It has 4 irregular singularities due to Hoyne functions. So dealing with them without a strong structure of mathematical compulsory fundamentals of the mathematics, it's really hard, because as I told, in the undergraduate program in here, that's not enough to continue to or deal with Hoyne functions. Of course, you are. It is expected from you after your graduation that you have to be able to solve differential equations, but those are actually linear differential equations, or maybe second or third order differential equations, and mostly they are homogeneous or linear. Important is that they are linear, so it is available to expand a series as a power series to solve these differential equations easily. But in Hoyne case, we have four singularities in our differential equation, and you cannot do this technique use, so you are in that very requisition to continue your research with numerical integrations, numerical methods in physics, which I am not good at yet. So yeah, we are still quarreling with them. We are still fighting with them, and just indefatigably we are doing that, and we will keep that. It's a pain, but the results are amazing, and I hope it will be published. I hope. Just a few months. Okay, those are actually the first topics I intend to talk about in this video. That's it.